explaining how to conduct a spring constant experiment. In this experiment, we are verifying practically how the equivalence of spring constants in series and equivalence of spring constant in parallel can be verified. That is, we are verifying the theoretical value with the experimentally determined value for the given two springs. So first of all, we need to take spring 1 and spring 2 separately, and we have to calculate the spring constant. So now I will tell how to take the readings for the spring 1. So we will consider spring 1 and we suspend to a rigid support, and to the end of the another end of the spring we will be suspending some dead load. So the dead load can vary from material to material. Here for our case I have taken 100 grams as a dead load. So by suspending the dead load, so it gets elongated, and we will be noting down the pointer reading A. So here the pointer reading for the dead load is showing at 15 centimeter. So to note down the pointer reading with initial load for 0.1 kg, that is A, it shows 15 centimeter. So we will be noting down 15 centimeter. So after that, we need to add 50 grams for each trial and note down the pointer reading in each trial. So we will be adding 50 grams. So the pointer reading came to 17 centimeter. So we will be noting for 50 grams pointer B, that is 17 centimeter. Again you add another 50 grams. So note down it came to 19 centimeter. So note down the pointer reading. So like that you repeat until W plus 200 grams. So then you have to subtract to know the displacement B minus A. So we will be getting the displacement for a load of 50 grams. So then we calculate force M into G. M that is 50 grams. That you have to take into kgs. That is 0.05 kg into 9.8. So in the similar manner we have to continue for all the trials. So from the values of F we can calculate the spring constant for each trial. Then we can take the average. That will be the spring constant of the spring 1. So exactly in the similar way we have to proceed, and we will be calculating the spring constant of S2. So I will explain the spring connected in series, how to calculate the spring constant. So the same two springs S1 and S2 now hanged in series, and the same dead load we will be suspending. And in the similar way, after adding the dead load, we will take the pointer reading A when the two springs are connected in series. So it is showing about 31.5 centimeter. So we will be noting down what is the pointer reading A for dead load, that is 0.1 kg. So that is 31.8 centimeter. Now in the similar way how we conducted for spring 1, you keep on add the load of 50 grams, and each time note down the pointer reading. So I added the 50 gram and the pointer reading B, now it is showing 36. So we'll note down 36. So in the similar manner you continue adding the load 100 grams, 150 grams and 200 grams, and each time note down the pointer reading B. From that we can calculate the displacement by subtracting B minus A, and then we can calculate force by considering mass in kgs, and we can calculate spring constant in series. So now I will explain how to conduct the spring constant when the two springs are connected in parallel. So remove the two springs. suspend them parallelly with the help of the two hooks. And for this case, the dead load 100 gram is not enough, so I am taking a dead load of 150 grams. I am taking the dead load of 150 grams and note down the pointer reading A for the dead load. So the pointer reading is reading at 18 centimeter. So now you keep on add 50 grams and note down the corresponding pointer reading B. So now the pointer reading is showing at 18. Now after adding 50 grams, so the pointer reading is showing 19. So you add 100 grams, pointer reading is 20. So the displacement is coming in some order. So that is as per the Hooke's law. So for each 50 grams, the displacement is 1 centimeter. So if the spring is of proper material, so it so happens each time when we add equal amount of loads, the displacement will be getting in a equal intervals. So then we will be calculating the spring constant in parallel, that is experimentally determined value. So that can be verified with the theoretical value K parallel is equal to K1 plus K2, which are of the spring constant of spring 1 and spring 2. So we should get K parallel experimental should match with K parallel theoretically. Similar manner, the K series theoretically it is given by K1, K2 divided by K1 plus K2. That should be matched with the experimentally determined K series. So whatever the results obtained, tabulate in the result. So K series theoretical should match with K series experimental. K parallel should match with the experimental